A very good morning, students. So in today's class we discussed about the work. Work done on a body by a force is equal to the product of the force applied and the distance moved by the body in the direction of force. So here the three important things is, first is product, that work is equal to the product of two quantities. What are that two quantities? The force applied and the distance moved in the direction of force. So here you can see that a body is there which is at the position A, and after applying force, on applying the force F, this body moved and changed its position from A to B. So the distance moved by the body in the direction of force is D. So the work done will be equal to F into D. Now we are going to discuss the three cases when work done is 0. If force is not applied, that is force is 0, then the work is equal to 0 into D, then the work is 0. Means if we are not applying any force, the body will not move, so the work done will be 0. Next is D equals to 0. If we are applying force but the body is not changing its position, it is not moving, then the work done will be 0. If the body moves in a direction perpendicular to the direction of force, then the work done is 0. So this is the third case, that whenever a body is moving in the direction perpendicular to the direction of force, then the work done is 0. So here I have taken an example. This is your sun, this is your earth which is moving around the sun in a circular path, and here you can see at every point this sun will apply a force of attraction on this earth. So the motion of the body is perpendicular. Here you can see it is making 90-degree angle, means it is perpendicular to it. So the work done by sun by the force of attraction on earth is 0. So we can say that whenever a body moves in a direction perpendicular to the direction of force, then the work done is 0. And in your book one example is given, that when a stone is tied with a string and the direction of that stone is perpendicular, that's why the work done by the force of tension on the stone is 0. So here you can see that my hand is the center point and the stone is moving around, and the force of tension on the string and the movement of this stone is perpendicular, so the work done is 0 here. So I hope it might be clear to you. And for D equals to 0, when you are applying force on a wall, the wall will not move, but you are applying some force, distance moved is 0, so the work done is also 0. Next is your units. Unit of work. We know that work equals to force into distance, so unit of force is Newton and that of distance is meter. So we will be getting Newton into meter, that is Newton meter, or it is also known as joule, which was named after the name of scientist James Prescott Joule. So if we want to define 1 joule, we can write 1 Newton into 1 meter. So it means that 1 joule of work is said to be done when 1 Newton of force is applied on a body and it moves by a distance 1 meter. Next comes another bigger units of energy, that is 1 kilojoule, that is equals to 1000 joule, and 1 megajoule, that is equals to 10 raised by 6 joule. 1 kgf equals to 9.8 Newton. If kgf is the gravitational unit of force, then the gravitational unit of energy will be 1 kgf into meter, that will be equal to 9.8 Newton into meter, that is equals to 9.8 joule. So this is again very important relations that you will be using in your numericals. Now comes the energy. So whenever we say that work is done on a body, its energy increases and in other words, the work done on a body is stored in the form of energy. And if any work is done by the body, then its energy will definitely decrease and the energy is spent while doing the work. So for example, if we say that a boy is playing football, he runs all over the field, so his energy is spent in doing work. He will continue to play until and unless he possesses some energy. If he doesn't have any energy, he will stop playing. So now comes the relation between work and energy. There is a direct relationship, that is, work is directly proportional to energy. If more energy is applied, more work is done. If more energy is spent, more work is done. If less energy is spent, less work is done. If less energy is spent, less work is done. So, how we can define energy? The work done on a body in changing its state is said to be the energy possessed by that body. And the unit of energy is same as the unit of work. So, how we can define 1 joule of energy? A body is said to possess an energy of 1 joule if it can do 1 joule of work or if 1 joule of work is done on it. Thank you. Have a nice day.